you and me both. But things don't happen around here in a hurry, as we know, John.
That's the truth.
But anyway, it's 6 o'clock, actually 6:01 tonight. I'm Terry Hancock.
Just me. I'm the only sweet
I'm
one.
going to be filling in for Nancy this evening. She's not available. And I just want to welcome everyone to the April meeting. And I know we have some friends from other astronomy clubs as well. I want to welcome you as well. And I'm hoping that in the not too distant future, we might be able to resume having the meetings back at the library.
You can't see that.
But anyway, so anyway, yeah, I just want to welcome everyone tonight, and I'm going to I'd like to introduce John Mansur, is the founder of Grand Mesa Observatory. John is also my boss, and it's great to have you here tonight, John. John is going to talk about and give us a short summary of what it takes or took in the mid-80s to get a satellite from Earth to orbit, including some of the pains and bloopers along the way. And John was the launch director for Cape Canaveral before moving to Washington and working at the Pentagon in the 70s and 80s. And it's a great pleasure to have John here tonight. Without John, I wouldn't be here. At least that Grand Mesa Observatory wouldn't be existent. It's all due to John. And he's done a great job. Anyway, I don't know how you want to play this, John, whether you want to leave any questions to the end of your talk, or whether you want to do it during the...
Wave your hand or something.
However you want to do it. We like to leave that up to the guest speaker to do it. So I believe John's talk is going to go for about 40 minutes. And
I'd like to go ahead and get started. It is a pleasure to talk to y'all. And my wife, Vicki, you wave your hand there, Vicki. Vicki is with us tonight. The observatory is built on the land that was her folks' cattle ranch and where she grew up, so it's kind of special to us. I was the launch director for the Titan 3C program, which at that time was the heaviest launch vehicle capability that the U.S. possessed. The moon rockets had long since been retired. And so the Titan 3 was the heaviest. But I thought I'd kind of give you just a quick introduction on how does a young kid from Western Colorado end up as the launch director at Cape Canaveral. Vicki and I both grew up she grew up on the ranch there where the observatory is. I grew up in Grand Junction. We went off to the University of Colorado to go to college. And from there, I went into the Air Force and into the through pilot training. Okay, you should have a picture of an incredibly young guy there. Is that what picture you got up?
Yes.
Okay. I went to pilot training, and after pilot training, I got into eventually here into the fighter world, and went to Southeast Asia in 1966, flying the RF-101 there's a supersonic low-level reconnaissance. We didn't do a reconnaissance supersonic, but we did it just right at the sound barrier over Hanoi. Unfortunately, I got hit on a run over North Vietnam and had a pretty spectacular crash in Udon Air Base, Thailand, and carried home on a stretcher. About a year and a half later, I got back on flying status. And about 6 months after that, I was back in Southeast Asia, this time as a forward air controller in a strange little special operations outfit. We were Air Commandos when I got into it, but they changed it to special operations thereafter because somehow Air Commandos sounded too much like carrying the pirates, I think. It was an interesting job in that we were flying in Laos, living on the ground in Laos, flying unmanned or unmarked airplanes, civilian clothes, and all like this, because by rule of somebody, we had no American military on the ground in Laos, so we couldn't be military on the ground. But and another day, maybe I can tell you about that, because that was a pretty fascinating time of my life. But I come back from there, and after a few more years of flying, the Air Force decided they wanted me to be an engineer. I had got my bachelor's degree in aeronautical engineering. They sent me back to get a master's degree in aerospace engineering. And I was 5 quarters into a 6-quarter program, and they yanked me out of school and sent me back to Southeast Asia, back to Cambodia this time, again in a special ops type situation. And I come back from that, and I spent a couple of years doing an aircraft research in the flight dynamics laboratory in Dayton, Ohio. And then I had a chance to get into the space program, and I volunteered for that. And my first assignment was when I got to Cape Canaveral, the 6555th Test Group, was to co-chair with NASA a ground operations working group for the new, at that time, interim upper stage booster. And this is, it was originally designed for the shuttle. That was the whole intent, was it was gonna be the upper stage that would ride in the shuttle and take the payload from the shuttle and either send it off to the outer space or put a satellite on orbit, equatorial type orbit. But it was just interim because they had something called the space tug that NASA was developing that was going to take over. So this was just interim, but then it turned out the space tug didn't work out, cost too much, didn't look like it was going to be very productive. So they decided that they would keep the IUS, interim upper stage, IUS, as the primary upper stage. But by now they had printed tons of documents that said IUS, and that was interim upper stage. Well, it's not interim anymore, so what on earth can you do? Well, you don't want to go change all that documentation that says IUS, so you have to come up with something that will work for an acronym, the IUS. And I almost got uninvited from a NASA meeting when I suggested the improbable upper stage or the impossible upper stage. But they finally decided they call it the inertial upper stage, which doesn't make a lot of sense when you come right down to it, because all of the upper stages are essentially inertial guidance, but at least it fit the acronym. And so what did we do as this ground operations working group? The IUS, we worked with the designers first on how the system is going to work, and then when they're ready to, before they could ship it to us, we had to build a facility to assemble it, and we had to do all of the necessary wiring and electrical and so forth to be able to test it from the assembly facility as well as from the payload or from the pad. But it was an exciting and adventurous time, but quite frankly, it was just working ground stuff, and I didn't come down to the Space Center to work ground stuff. And also one more picture. Here's a picture of the IUS. This is a artist rendition, having deployed.
Excuse me, John. Do you think you could get a little bit closer to the microphone?
Okay, is this better?
Yeah, that's better.
John, you're in the tunnel again. Can you fix that?
I don't know how to fix it, Vicki.
Okay.
Anyway, this is the Galileo spacecraft on top of the IUS before it, again, it's an artist rendition. But one of the first things I got involved with, only from the sidelines, if you will, a few months after I got to the Cape, was the launch of the Titan Centaur that put the Voyager spacecraft up in orbit. And I was so blown away by the power and the capability of that rocket that I determined that's what I wanted to get involved with, because here you're really putting stuff in space. And so I started kind of working my way toward getting involved with that program, and finally ended up understudying the current launch director for a good spell, and convinced the commander to make me the next launch director, the test group commander. But I had to get approved by the commanding general out in Los Angeles. And so I was pretty nervous about that. And I went out to interview him, talk to him about it. And he said, "So John, you want to be the launch director?" And I said, "Yes, sir." And he said, "You need to understand that if you or any of your people put one of my rockets in the water, and I can show that it was the fault of any of your launch team, I'll fire you, and that'll be the end of your career." He said, "You understand that?" And I swallowed a couple times, said, "Yes, sir." He said, "And if you put two of them in the water, I don't care whose fault it is, I'll fire you because you're too unlucky. You still want the job?" And after a couple of swallows, I said, "Yes, sir." And so I became the next launch director. And just a couple of words about this Voyager. This is one of the highlights of my life, is watching this Voyager do its thing. Voyager 2 launched in August of 77, 2 launched actually before Voyager 1. And both of them went out and used Jupiter, the gravity of Jupiter, as a slingshot to launch them on out in outer space. And if you see in the picture here, the one that goes straight up, Voyager 1, went past Neptune, or past Jupiter, and then past Saturn. They got a bunch of great pictures of Saturn and Saturn's moon Titan, and then it headed for outer space. Voyager 2, they elected to again use the slingshot, but they sent it over on what was called the Grand Tour, and it went by Jupiter in July, 2 years after launch. It went past Saturn 2 years after that, went past Uranus out there 5 years after that, and Neptune 3 years after that. And here a couple of years ago, it went into interstellar space, and it's still sending data back. And that's just, to me, that's absolutely amazing. And it's powered by a small nuclear generator, which, by the way, caused a great lot of grief, because there were a lot of worrisome people that were convinced we were going to launch a nuclear bomb, and it was going to blow up on the pad, and it was going to, well, none of that was even possible. But it still, there was a lot of upset about the fact that they launched a nuclear payload on that rocket. But you had to have some, if you're going to go out that far, you have to have a nuclear radioactive type generator, because you're not going to get any sunlight to power it, and you can't carry enough liquids on board to last anywhere near that. So you had to have a radiation generator, and it has worked phenomenal. And now I'll get off one of my favorite topics there and get on with what I wanted to talk to you about. This is my Titan 3C. This was a wonderful rocket. It was the only rocket we had that would boost the satellites, and the satellites I launched were all DoD top secret GWIS reconnaissance satellites for either the Air Force or the CIA, and what the press calls spy satellites. We call them reconnaissance satellites, but they're geosynchronous satellites that go up and park wherever you want them to park, and they travel. Their orbit speed is the same as the orbit speed of the Earth, and therefore they stay stationary, which is why they're called geostationary. But let me just talk a little bit about the rocket. You see the two boosters strapped to the side. These they're 10-foot diameter, and each segment is 10 foot high. And surprisingly enough, those rockets are made out of butyl rubber and powdered aluminum. And that's what makes them go. And each one generates a little over 1.5 million pounds of thrust when it ignites. And this red tank you see on the side down here on the lower right is a hydrazine, which is a very nasty propellant that is squirted into the nozzle, and it has 8 little nozzles around the main nozzle for the booster. And depending on what kind of a nudge they want to give it, if they need to correct it a little bit, it squirts a little bit of hydrazine on that side of the nozzle, which changes the direction a little bit. But kind of a story that you won't hear, probably never hear again. We had one of these segments, whether it was cracked when it arrived or it got cracked after it got there, the propellant inside, we found a flaw in it. Now, we couldn't use it because everything has to burn at the specified rate or you're going to have a disaster. So what do you do with a 10-foot diameter, 10-foot long chunk of solid propellant? Well, my first answer was send it back to the manufacturer. The manufacturer said, it's not our problem, it's your problem. And they wouldn't take it back. And so here I am with this big chunk of propellant that I don't know what to do with. So we finally carried it out to the beach, put it on the beach. We rigged up an igniter on both ends with the assumption that it wouldn't go propulsive. It was burning from both ends, and we burned it on the beach. And it was a very spectacular beach fire, if you will. And interestingly enough, after the smoke all cleared and everything cooled down, the sand underneath it had melted to a depth of about 4 foot, and it was bright green stone that sand had melted to. And of course, all of the launch crew and everybody got chunks of green sand. So anyway, those are the solid boosters that pushed it up. And one of my nightmares while I was the launch director was that only one of those would light. Now imagine what would happen if only one of those lit. The thing would go cartwheeling across this part of Florida. But that never happened, thank you, Lord. Then in the core vehicle is 2 stages, and it's powered by hypergolic propellant, which means it was hydrazine and a fuel called amazine 50. And they're hypergolic, which means you don't need an igniter. When those 2 liquids come together, it's instant fire. And then above that, you have what was the trans stage, and eventually it turned out to be the interim upper stage or the inertial upper stage on later versions after it became operational. But the trans stage here was also a liquid propelled upper stage. And then the payload inside the payload pairing here. Let me go on to the next. This was my launch area. This is called the Integrate, Transfer, and Launch area. And this whole area you see there was the Titan launch operations area. And I don't know if you can see my cursor on your screens or not. Can you see my cursor?
Yeah.
Okay. This building here is the vertical integration building. The core vehicle would come in, land on the runway at Cape Canaveral in a C-141. They'd be carried by truck over to this building, stand it up, and then start the testing. The launch control center that launched all of the Titans is on the 4th level of this building. And we could stack 4 Titans at a time. And it's hard to get a perspective of the size of that building, but it's something over 14 stories. Anyway, this building over here, this one over here, is where the solid motors would come in, and they would come in by rail. And so the core vehicle would be assembled here, and the solid motors would come out to this next building out here, which was called the SMAB, which stands for Solid Motor Assembly Building. And they would stack them in here until you'd have completed and tested solid motor rockets, one on each side. And the core would be transported out on the launch platform, which was lifted up and set on a railroad car. And my railroad train would trudge it out here to the high bay of this one. And at this point, the 2 solids would be joined to it. Again, a host of testing going on. And then the train would trudge it on out to the pad. A little bit better picture of you can see the tracks going out. It would take it to the SMAB, and then it would go on out to the pad. And another picture of the SMAB, and you can see here where of the VIB. I mean, we're assembling 4 Titans right at that picture. Then we come out to the launch pad. A lot of exciting things happen at the launch pad. Once the train gets here, they lower the rocket onto the pilings that it sets on for the actual launch, and the train departs. And here you see just before launch time, the rocket setting here. Now, during the assembly, this big building back here, this assembly rolls forward and surrounds the rocket. And there's a door, and I'll show you a picture of it a little bit later, that nestles around the payload assembly, and it snuggles right up to the rocket there. We close the door once the payload is inside, and do all of the processing. But it's a clean room, and when this huge door, which weighs some 60 tons, this big huge door closes, then they spend 2 days just filtering the air, because you can't have contaminants that would mess up the lenses or whatever. So you spend all this time getting it clean, category 100, what they call 100,000 clean room, which means no more than I forget how many particles per 100,000 cubic inches of space. But it goes through a HEPA filter for 2 days, and you'd think it would be absolutely clean at that point, and it was, except one time on my second launch, we were into the point of assembling the satellite, and the satellite was almost completely assembled and checked out, and I got a call that said, Colonel Mansur, you need to come to the pad and come up to the clean room. Well, to get into the clean room, you have to wear a bunny suit and boots and a hood and a face mask and on and on. And I got up and went in, and there's hornets flying all over the place. When the door had been opened, they had come in and laid their eggs on the liner of the door. They closed the door, and some days after it had been all pumped down, I have no idea how many hornets buzzing around in our clean room. How do you get rid of it? You can't spray, because if you spray anything in there, you can contaminate the sensors and what all. So the solution was fly swatters and vacuum cleaners. And so you see all these guys in bunny suits running around with fly swatters killing hornets. And it took us 2 days to get rid of all the hornets. We had another interesting episode out there when we lost power on one level. And when they checked out, they found out the reason was because a rattlesnake had crawled into one of the switch boxes and fried itself. So anyway, once the rocket's out there, this moving tower surrounds it. This thing that juts out at the top of the tower here, there's a crane in it. They use the crane to bring the upper stage up and set it in place. And they use the crane to bring the payload up and set it in place. And they close the door, and the payload is all enclosed in a big bag. And after they pump all the contaminants out, the bag is removed, and they spend a lot of time assembling the satellite. And we had a satellite in the 3 or 4 days before launch. They're doing the last bit of checkout, and somebody from the top level dropped a small metal, what's called a keeper. It was just a thing to keep the screws from coming unscrewed, if you will, down into the satellite. And just imagine, tink, tink, tinkling. Well, this thing is down somewhere inside that satellite. You can't launch like that because it's liable to short out the satellite. So what do? Well, you're going to take it all back off and take it back, maybe all the way to the factory, and everybody's wringing their hands. One of my young sergeants, actually 2 of them, got up there and they laid on their bellies on this top level platform with a pair of binoculars. And they started just looking down at that spacecraft. And they finally spotted that little keeper down there. They got a long bamboo stick, and put a little magnet on the end, got it out, and we were able to proceed. And someone calculated out that it would have probably cost somewhere around $100 million if they had to go back and start over. Okay, let's talk a little bit about the launch, what's involved in actually launching. As the launch director, I had a launch controller, and he's the one that actually, and he was a senior captain, Air Force captain, and he was the one that actually babysat. He was they call him the missile mama. He was responsible for tracking everything that happened and reporting it to me. And the rocket is all assembled here. And one of the scariest parts of the whole thing is both the solids and the core vehicle are all equipped with explosive devices, so that if the rocket malfunctions, they can send a command destruct, and these explosive devices blow up, and it blows up the solids, it blows up the core vehicle, to make sure that it doesn't go off and land in Miami or somewhere. And as a launch director, I always just worried me no end that someone would accidentally detonate that send the command and destruct system signal. And believe it or not, the person that sits there, and they have a screen in front of them during the launch with 2 red lines that go up and angling out from the launch pad. And the launch pad signal is at the bottom. And the rocket takes off and it tracks up. And as they watch this dot travel out, if it crosses the line on either side, that young captain that's sitting there hits a red button and sends a signal and blows the rocket up. And it just worried me no end that somebody would inadvertently blow up my rocket. So 2 days before launch, I always went down and sat down with the captain that was going to be doing this and made him walk through everything that they would have to see happen before they could push the button. And all 3 of my launches, the young captain that had that responsibility was a young lady who was one of the coolest, most professional young people I think I'd ever met. And that's a job I wouldn't want, because when we go through the dry runs, and she had to go through about, I have no idea how many dry runs where they would simulate the rocket going off, and she had hit the button and say, "Command signal sent," and that would mean the rocket had smithereens. But never had to happen. Never happened on one of my launches. Okay, now let's talk a little bit about the launch itself. And some of the things that lead up to it. All of the days before the launch, you call it L45, L-45 means 45 days away, L-30, so forth. You get down to L-1 and it switches to T. And then it's T-minus 24 hours, T-minus 18 hours and so many minutes until you count down then to T-minus 0. And roughly the last 30 days before launch, it goes into a 24-hour operation. And when that happens, all of the whole tower is lit up 24 hours a day. And as soon as we would light up the tower, we would have a visit 12.5 miles offshore from a Russian trawler. Now, they called it a Russian trawler, but it was obviously a tracking ship. It had antennas you wouldn't believe spouted all over it. And when we were launching these particular satellites, it was important to the satellite operator that the Russians not get all of the launch data and to know exactly where this thing is going. And it had a certain amount of stealth capabilities, the rocket did, or the satellite did. And so, but as soon as we light up the tower, 2 weeks after we light up the tower, this trawler would show up offshore, 12.5 miles. And so I got this idea that, tell you what, let's light up the tower. We're still 6 months from launch. That's okay, light up the tower. And we'd light up the tower, and 15 days later, the Russian trawler would appear, and then we'd turn the lights out and he would leave. And we did that about 3 times. And then when we got to our final launch, we turned the lights on and he didn't show up. So I felt very pleased about that. And one other quick story about the trawler. I came back after I spent 4 years in the Pentagon. I came back down as the center commander, which means that I had command of Cape Canaveral and Patrick Air Force Base and all of the downrange tracking sites and 2 ships and what all. And the trawler had come and parked in. We'd always send out notice to mariners saying, stay clear of this corridor during these hours. But the trawler had parked right in the middle of it, so we were going to have to launch right over him, and safety objected to that. And we had, at that time, we had AC-130 gunships flying security orbits around the pad, and not to shoot their gun, but to use their sensors to make sure we didn't have intruders at night. And I had one of the 130s up, and I called on a secure line, talked to the pilot, and said, I'd like you to go out and orbit that trawler. And when you get out there, call on our common frequency and say, I've got him in my sights, am I cleared to fire? And let's see what he does. And so this AC-130 gunship went out and made about 3 orbits around this trawler and said, I've got him in my sights, am I cleared to fire? And then the guy put in full steam and departed the area. So, there's some things to be said for that. When it come time to launch and you get down to L-9 minutes, there was an automatic built-in hold. You'd stop right there. Everybody check all their systems, make sure everything's good. And then they'd pick up the count, and about T-5 minutes, they would do their final count for the launch controller would read off the stations, propulsion's a go, safety's a go, guidance a go. And they go through all these, and when they got all through and all of them are given a go, then they would say, launch director, we're go for launch. And then my only contributing words to the entire launch was, you're cleared to launch. That was my only line. And then the rocket would go. And it was 119 seconds after launch, the 2 solids would burn out. And at 5 seconds before they were jettisoned, the core vehicle would launch its rockets, its motors, and stage one would go, and 2.5 minutes later, you'd hear the call, stage one cut off, and then stage two ignition, and 3 minutes later, stage two cut off, and then it would free fly for anywhere from 5 to 7 hours before the trans stage would fire. And as you're sitting in the launch control thing, the one thing you listen for after you get that second engine cut off is they would say, through the African gate. What that meant was the thing had gone into orbit such that if it had to be blown up or if anything went wrong, the pieces would no longer land in Africa. So when they said through the African gate, that meant that it was in orbit. 7 hours later, 5 hours later, whatever, we would get a call that the trans stage had ignited, first stage had fired, and then a few minutes later, the second stage would fire, and then it would continue on for some hours and put the satellite in geosynchronous orbit at 22,000 miles. And it was a matter of pride that when it would get up there, it would be within 30 to 40 miles of the target of where you'd wanted to put it, 22,000 miles up. And one of the other things that was kind of interesting, we had certain areas out in the launch path that you couldn't get the downlink data to keep track of what's happening on the rocket. So we had an airplane called the Orion, Advanced Range Instrumentation Aircraft, which was a Boeing 707 with this terribly ugly nose out here that's got some exquisite radar gear in it. And these would deploy out of Rio de Janeiro in Brazil and fly out to the mid-ocean point. And they had to be out there before we could launch. And so it was another peg in the game. This is you got to forgive the silly guy with the grin here, but after I retired from the Air Force, I went to work for Bechtel, and we built a new complex 40, and I was the senior Bechtel rep in that. And what I wanted to show you here, this big flat place that you see here, that's the door that swings open, and the payload assembly room is behind that. And so when I say that it's big, this is some roughly, I think it's 90 feet or 100 feet, don't remember for sure, from here up to here. So when that door opens, it's a big door, and a lot of places for hornets to lay eggs. One other picture, and then I'll answer any questions anybody might have. This is my wife, Vicki, and this is the Secretary of the Air Force, Pete Aldridge. And this is a painting of a Titan III launch painted by my wife, which was accepted into the Air Force art collection and hung on the office in the Secretary of the Air Force for about 4 years. And the last we heard, it was hanging in the old executive office building in Washington, D.C. in the Capitol. Okay, enough for me. I hope I haven't bored you to tears, but any questions or thoughts or all's quiet out there.
I think outsmarting that trawler was pretty good.
It what?
Outsmarting that trawler was just a gem.
That was always a challenge, to try to figure out how to snooker the trawler. I had, when I was the center commander, part of my command, if you will, the Russians weren't the only ones that parked trawlers off of your launch point. We had one that parked off of their launch pad off the coast of Russia and up in the Arctic. And one night, in the middle of the night, 2 o'clock in the morning or so, I got a call, and said, "We've got a real problem. The ship is stuck in the ice." And I said, "Okay, we'll get an icebreaker on the way." And they said, "Well, it's stuck in the ice about 12 and a half miles off the coast of Russia, and the wind is blowing the ice toward Russia. And the Russians have got a whole group of people that are standing out there at the 12-mile mark, just waiting for the ship to get there." And I said, what am I supposed to do about it? I'm in Florida, for heaven's sakes, but other than worry. And so we start communicating back and forth. All of their radios and all their gear we had thermite grenades set, that all they had to do before the ship would be captured is you destroy everything. And I'm down to just almost to the point of saying, okay, we got to do this. The wind changed and started blowing back away from Russia. Great relief. One of the goofy story about that same time frame, while I was the center commander, since when you're commander of a major facility, you have to be within contact with the command post within, at that time, 60 seconds. So if you had to go to the bathroom, you carried a radio with you. If you were in your car, you had a radio with you. And if you're at home, I had a red telephone in the living room. I had a red telephone in the bedroom. That if you pick it up, you don't have to dial. You pick it up, and the voice on the other end says "command post," and you're automatically connected. Well, in the middle of the night, my black phone rang, and I answered and said, "Colonel Mansur, this is command post." Choke, cough. "Sir, the command post that Andrews has called us," and cough, choke. "They said your cat is calling them on the red phone." And I said, "What?" And I jumped up, and sure enough, the stupid cat had knocked the phone off. And the sitting there, and the guy on the other end is saying, "Command post." And the cat's going, "Meow, command post, meow." So my cat was talking to the command post. And I never lived that down. That came up more often than I like to remember it. How's your cat doing? Do you have any more comfort? I took those phones and I put a big rubber band around them to hold that headpiece on.
John, we have a question from Frank Wilkinson. And his question is, thanks for sharing the story of your fascinating career. Of all of the interesting parts of your work that you did, what do you miss the most?
That's a really good question.
The adrenaline.
What'd you say, Vicki?
I said the adrenaline.
Adrenaline, yeah. I had, I had an awesome Air Force career. I never had a job in the Air Force that I didn't love. I had an opportunity while I was at the Pentagon. I was the military assistant to the Undersecretary of the Air Force, who was also at that time the director of the National Reconnaissance Organization, which that organization controlled all of the reconnaissance resources of the country, including the SR-71, the U-2s, the reconnaissance satellites, all come under the National Reconnaissance Organization. So being the military assistant, the director of that meant that I had an opportunity to be involved in and know about all sorts of incredibly wonderful things, including, and let me see how I'm doing on time here, including, if you remember when they went in and struck the Libya for, what was his name, the bad guy in, anyway, this was the mid-'80s, and Gaddafi, Omar Gaddafi, was wreaking havoc in that part of the world, and they sent in some F-111 bombers and struck his compound, and this was before the days of being able to transmit pictures over the airwaves. So we had to wait to get the film back from all that. A few hours, and they flew it back on a a supersonic airplane. And I was in the, they came to my boss because he was the director of the NRO. And we carried it into the Secretary of Defense and Secretary of the Air Force and sat down and watched the first, they were the first ones this side of the ocean to see the imagery. It was really neat because they've been told they could not hit Gaddafi's quarters. That was off limits. And had the camera film from the weapons operator, and they're coming in, and he's got the crosshairs exactly centered on Gaddafi's quarters. And it's just centered. And at the last minute, he moves over to his target, hits his target. But you could tell he really wanted to put one through Gaddafi's front door. But so I guess, you know, just the adrenaline. There was always something exciting going on. My year flying up in Laos, I flew 505 combat missions, 1,100 combat hours, and that was incredibly exciting. I could have lived without crashing the RF-101. That was too exciting. And at the time in the space program, you're cleared to launch, and you realize that you're committing in my third launch, the satellite itself was valued at $750 million, and the rocket was another, I think, 200 million. So the two of them together were almost $1 billion. So when I say you're cleared to launch, I'm committing nearly $1 billion of U.S. resources. And that sort of takes your breath away a little bit. And but that was an exciting thing to do. We had one other story, and then I promise I'll quit. We had the rocket was on the pad, the satellite was up. We were within about 36 hours of launch, and a big thunderstorm came through. And in the middle of the night, always happened in the middle of the night, I got a phone call. They said, we've started the lightning strike procedures. And the rocket had been hit by lightning while it sat on the pad. And it somehow didn't hurt the satellite, but it fried all of the electric systems in the rocket. And it took us almost 9 months. It just literally rebuilt the rocket on the pad. You had to replace all of the wiring and test all of these actuators, and all the testing, and went on and on and on. But then when we finally launched it, was a 100% successful launch. So I could have lived without the lightning strike. I see there's a couple more comments down there, Terry, on the chat.
Yeah, from Ken Allaby, he wants to know how many decibels from the launches.
How many what?
Decibels? The
Decibels for the launch.
The sound level.
The sound, yeah. How loud are they in decibels?
They were. I don't know in decibels what it was, but the first shuttle launch. You know, my Titan area that I showed you there, the security to get in there was incredible. You had to have a badge to get on the Cape. That badge had to have a special mark before you could get into the ITL area. You had to have another special mark before you could go out toward the pads. You had to have another special mark to get on the pad. So really highly classified because of the satellites we have. The first shuttle launch, somewhere up in the astronomical brains of the bureaucracy, decided we needed to let the public get in and be able to watch the launch. So they opened my area up to bring cars in for people to come and watch the launch. Well, this was only about 4 miles from the shuttle pad. And so when that launched, when that shuttle launched, the vibration, the noise, you could feel it in your chest. The rumble was just, it was just incredible. And it was so close that they never let people be that close. That was the last time they ever let people be that close to the launch. And the funny thing about that is that, you know, the thing goes, you got this big cloud of smoke, and the smoke starts drifting towards us. Well, that smoke is basically the moisture is hydrochloric acid. And we've got all these cars out there, and I'm on the PA system saying, everybody get in your car or get in the buildings, in your car or in the buildings now. And I had some of my firemen hook up a fire hose and told people as you drive, if you'll drive through, we'll hold your car down and get that acid off your car. Well, a few of them took advantage, but most of them just left. And it ate the paint off of all of the cars. And not all of it gone, but you have bloops of missing paint. And of course, they've all put in claims to the government, and believe it or not, the government paid to have all those cars repainted.
To help answer the question, you can hear those things go from halfway across the county.
Yeah.
If that gives you kind of an idea of the volume
We live
of the sound.
roughly 35 miles from about 35 miles from the Cape. And if we're outside, we can still hear the launch.
No, the reason I asked was you can go and watch a top fuel dragster from NHRA, and they're side-by-side vehicles, each having 11,000 horsepower, and they're powered by nitromethane injected. And when they take off, when they launch, it's literally like having your insides rearranged.
Yes.
It's like a concussion. And that's the loudest noise I've ever heard. I mean, we're right there at the launch location. So I was just curious. You hear the cracking on the TV of the air crackling. So I was just curious, how loud is it?
And I don't have an answer to that. What the decibel
It's
level,
loud.
depending on how many miles away you are. But it does. You feel it in your chest when the vibration and the sound waves just rattle your whole body when that thing goes.
Yep.
Someone had a question: is Vicki still painting? She had quit. She hadn't painted for 20 years, and she started again here about a month or so
2 weeks ago.
2 weeks ago. So I'm excited to see that. We have some other questions out there, Terry.
I just Googled how loud is a rocket? And it says here, powerful, it does, I didn't put down the type of rocket, but it says here 180 decibels. So I don't know how that compares to a dragster, Ken. What does a dragster produce?
Similar.
Oh, is it? Okay.
Yeah, but it's only for a brief second, you know, at the initial launch.
Right.
And when you have them side by side, 22,000 horsepower. And I've heard jets from F-15 to F-35 fairly close. And I didn't get that same feeling as I did with the dragsters.
Each of these solid motors kicked out, like I said, 1.5 million pounds of thrust. And I have no idea how that converts to horsepower, but it's a lot of horses.
Well, it's 8 Gs on takeoff in the dragster.
Yeah.
That's a lot of G's.
Yes.
Any other questions?
They do 0 to 100 in 0.7 of a second.
There's one other point I'd like to make. When the Titans finally phased out and they were replaced by the Atlas V, which was Lockheed Martin rocket. When the decision was made to build a space shuttle, all of the space research money went into the shuttle. The space launch vehicle money went into the shuttle, building the shuttle. And when the shuttles, they only built 5, and when they obviously had a lifespan, we had done zero research in new motors. And so the Atlas V, which is what our country still up until SpaceX still depended on, is to lift our heavy payloads, including all of our reconnaissance satellites and so forth, is powered by a Russian motor that we buy from Russia. If that doesn't sort of make you nervous, because we had not developed any new rockets, and so we had to buy it from the Russians, which got very complicated when you have Russians there that they have to be on site because it's their motor, and yet you don't want them to know what you're doing in the payload up above, and it got real complex.
Well, thank you, John. Has anybody else got any questions? Okay. Well, John, I want to thank you very much for tonight's talk. That was very enlightening. That was really great. Were you going to say something then? Were you going to say something, John?
Yes, I thank you all for listening, and I hope I didn't bore you. I get kind of carried away on that topic.
Yes, I'm sure.
All right. Well, thank you all.
Thank you, John. If there's anyone here for the first time, if you'd like to unmute yourself and tell us who you are and where you're from. If not, I just wanted to ask Ken if you wanted to have a business meeting tonight, Ken, or if there's anything that anyone would like to discuss before we close the meeting.
Well, all I would want to say is I saw all the names for the attendees. I was very happy to see so many club members listen in. So it's a lot that we can build on, and certainly absent meeting in person, I think we've been able to carry out the club's mission and goals as best we can. So thank you all for signing in.
All right. Well, Terry, Vicki, and I are going to sign off. Thank you all. It's been a pleasure talking with you.
Yeah.
Bye-bye.
Thank you, Vicki. Thank you, John. Have a great night. Thanks very much.
Bye.
All right, guys. So has anyone else got anything they would like to talk about before we close the meeting? No? Okay. Well, thank you everyone for participating, and I hope you have a great night and look forward to seeing you all at the next meeting. Nancy should be here for then. Okay. God bless you all. See ya.
Thank you, Terry.